Hi, Geometry. This week we're going to look at a couple facts about circles. So on your first one, let's take a look at the document that's called radius, circumference, and arcs. Now we know a lot about this stuff already. For example, we know that the circle is named by its center. So you could either call it circle C or you can use this little symbol for circle. Okay, so we already know that. We also already know about radius. That radius is the distance from the center to any outside edge of the circle itself, and that is a radius. So if they show us one radius, we know every radius in that circle is going to be exactly the same. So if this radius is 2, then x has to be equal to 2 because radius are always the same in the same circle. All right, so on to a new word, and we did this in our vocabulary last week, which was a chord. A chord has to stop at two sides of the circle, but it doesn't go through the center. If it does, we would call it a diameter. So any segment that starts at one point on the circle and goes to another one is called a chord. Okay, doesn't matter where it starts, where it ends. It could start here and end right here, right next to it. It could start over here and go all the way over to this side and just barely miss the center. All of those would still be considered chords. Okay. Then we have our special type of chord, which is a diameter. This is the one that starts at one end, goes to the other end, but happens to go through the middle. So still has two endpoints on the circle itself. Excuse me, so that's a diameter. And what do we know a diameter is? A diameter, we always know, is that a diameter is equal to two radiuses multiplied together. Okay, so if they, in this example, give us from G to H is 2, then we know this is also 2, and so the diameter would be equal to 4. And in our last one, the 10, see where they put the 10? See how they put it right in the middle of that entire diameter? So they're telling us the entire diameter is equal to 10. That means that a radius has to be 2 times what to equal that? It's got to be a 5. It's got to be half as much. All right, all of that should be pretty much review. Okay, we also reviewed circumference. So in circumference, we know that the formula for circumference, first of all, is just the distance around the edge of a circle. So pick any starting point, go all the way around the outside edge of a circle, and when you return, that distance is called a circumference. And we know the formula for circumference is you can use either diameter or radius in it. So if it's diameter times pi. And if you take out diameter and say diameter is 2 radius, then you get the 2 and the r instead of the diameter. So you can use either one. Okay, so in this worksheet, they're using 3.14, I believe, for pi. So in this example, 7 is the diameter. So we would say that the circumference is equal to 7 pi. And if you multiply pi, they're saying it's about 21.99. I'll take their word for it. Okay. In this one, they gave us the radius. So in this one, you can either figure out what the diameter is, which is pretty easy, or you can just go straight to the circumference formula that uses radius. So that would be 2r pi. So that'd be 2 times 9 times pi. That'd be 18 pi, and they're saying that's about 56.55. Okay. All right, so we've done a little bit of circumference. Okay, so that is basically what we're doing. So if on a computer practice, they give you the option to use pi, just use the symbol. We have the symbol on our calculator, that works too. If not, they're saying you can round to 3.14159. I just use the pi button on my calculator to be honest. All right, so next part we're going to talk about is arcs. Now we had that in last week's about what a minor versus a major arc is. So an arc is just a piece of our circumference. It's a distance around the circle, and if it doesn't go more than halfway, it's considered a minor arc. If it goes more than halfway around, more than 180 degrees, we consider it a major arc. And the symbol we use for arc is this upside down U that kind of looks like part of the circumference. Now, I think in last week's practice, I didn't have the opportunity to use that symbol. It wasn't available to me. So then I just called it arc AB. You can use either one of those as fine. Okay. All right, the other thing we know is that if it goes exactly 180, that is just considered a semicircle, right? So exactly 180 is a semicircle. So that would be one that goes from A to C or one that goes from B to D. So A to C or B to D, both of those are considered semicircles, right? All right, here's the other new thing that we didn't talk about last week. So I'm going to change colors here so it makes sense. Okay, is they are saying find DEF, DEF, and if DE is 127. So what they're telling me is that this arc from here to here is 127, okay, and they want me to find DEF. So DEF is the rest of the part around, right? So I need to figure out what this amount is, and I already know to go from E to F is 180, so I can even do math to the arc symbols as well. So we would call that 180 plus 127 would give us, is F to E, yeah, that looks okay. So what did we do? So we said D, oops, I misread it. No, I'm okay. DE is 127 degrees. We know from here to here is 180. So if they wanted us to find DEF, I think I would do 127 plus 180, which would be 307. So what happened? Maybe they didn't really mean E and F was an actual semicircle. Do you think that might be possibly true, that this isn't to scale? Let's see, what did they do? Well, they went around the entire thing and they said that DEF plus DE, wait, DEF plus DE, well, that's not right. How can DEF plus DE be equal to 360? We don't know that. I like my answer better. Okay, I like the 307 better. I'm not sure what they really meant right there. And if I missed something, then I apologize. Maybe you can explain it in a comment or something if I'm missing it. But if I want to figure out what DEF is, then I want to be able to go all the way around the circle. And I would want to start at DE, which we already know is 127. And then I'd want to go from E to F, which is 180. And if I add those two together, I should get 307. I think it's 307. Let's just go with 307. All right. So here is our last little bit about angles. And that is, we talked about a central angle. This is new. Okay, we talked about a central angle. We said a central angle is an angle where the vertex is part of the center. So let's say I was looking at an angle that looked like this, and let's say I called that 100 degrees. Well, guess what? That also means that this arc that matches that angle is also 100 degrees. So if I know what the arc is, I know what the central angle is, and if I know what the central angle is, I know what the arc is. Okay, so that they are similar to each other. So let's just try one more. If I were to draw you a circle, and if I were to tell you that to go from here to here, this arc right here is 90 degrees, what could you tell me about this angle at the center? You could tell me that this angle is a 90-degree angle at the center as well. Cool. All right, so next part we're going to do is we are going to go and practice some of this about radius and diameter and chords. So when we get to this part, let's see, how many questions are there? Because we are definitely not doing all of these. These are way too many because we are also going to practice on quizzes this week for a quiz score. So I see 24. Let's do every third problem, shall we? Okay, so this is going to be 8 practice problems. So do every third. Now, I wonder how many are actually going to watch the video to realize that they only had to do 1/3 of the problems. So we're going to start out with problem 3, 6, 9, 12. See how we just keep adding 3's to them? So let's go through and circle them. So we're going to do problem 3, we're going to do problem 6, we're going to do problem 9, we're going to do problem 12, we're going to do problem 15, and if I keep adding 3, I get 18, and then another 3 is 21, and another 3 is 24. Okay, so we're going to do one of these together. Okay, so the first one is number 3, and the directions say, nope, it's each individual. Okay, so the measure of the arc that goes from A to C, T to C. all the way around this way is 276 degrees. And it says find the measure of the angle that goes from measure of A to C. Well, that's just the rest of the circle, right? So I'm just going to go and do 360 for a total circle, subtract out 276. I'm going to have to borrow. So I'm going to get 10 minus 6 is 4, 15 minus 7 is 8. You're welcome to use a calculator. I'm going to get an 84. Okay, so that problem is done. Now, on this worksheet, what I kind of like about it is at the bottom of every single page, you get a chance to bubble it. So if you're not seeing your answer down here, it means you did something wrong. So I can tell that I did that okay because the answer is down there. Okay, so you're going to do every third problem on this worksheet. Okay, so the other thing we're going to work on today is this theorem of intersecting chords and intersecting tangents. So intersecting just means their paths cross. So any two chords that happen inside a circle, they have to be inside a circle because that's the definition of a chord, right? They have to have two endpoints on the circle itself, and then it's just the segment that connects those two together. So they've named these distances. They've named this distance from this corner to here is called D. They've named this corner over here B. This segment over here, I shouldn't be saying corner, I should be saying segment. Okay, this segment is an A. And there's this theorem that we know about them, and that is that if you multiply the two parts of the chord, so that would be A times B, notice they're on the same chord, A times B is going to equal C times D. And so we're just going to practice that theorem a little bit. So here's a couple examples. Okay, so I know that 3 and X are going to go together, and then on the other side, I have 2 and 6 are going to go together. So if I wanted to solve what X is, I would get X equals 4. So this must be a 4 to make that work. Then we'd have 3 times 4 and 2 times 6, and those would equal. Now, if there's an X in the problem, we're going to have to do a little bit of algebra. So we're going to do 2 times this amount. So notice they put them in parentheses to make sure we multiply 2 times the whole thing. And on the other side, we have 1 times X plus 10. We distribute everything out. So 2x plus 8 and x plus 10. My goodness, what is happening with this worksheet? Okay, then we're going to subtract x's to get them on the same side. So if I do that, I will get 1x plus 8 equals 10. And then I'm going to subtract the 8 over, and I'll get x equals 2. Now I can double check that again, in that this side would now be a 6 and a 2. And the other side, if I plug in a 2, would be a 12. And a 1. And yep, those two do multiply to equal each other. 6 times 2 is the same as 12 times 1. Okay, so that's the chord practice, intersecting chords. The other one is something about tangents. So anytime you have a tangent to a circle, so remember the deal about tangent from last week is it has to be a line or a segment that just barely touches the circle at one exact place. And we call that one point the point of tangency. Okay, so this is a theorem about two tangents to the circle. So we have this line or segment AB that touches the circle only at B, and then we have a second tangent that also starts at A, and it goes and touches the circle at a different point. Okay, so the key point is they have to connect at a point on the outside, which they should if you take them far enough. And if that's true, then the blue distance, so this blue measurement that goes from here to here, has to be equal to this pink measurement over here. And so they wrote it as AB, oops, hello. So they wrote it as AB equals AC. Okay, so let's look at some examples of that. Okay, so here is our point A. We have a point of tangency at B and C. So these are two tangents that go through the same point on the outside. So this side should equal this side. So that means X must be 8. They have to be equal. Over here, we're going to have to do some algebra. So it says E to F is X plus 3 and E to G is 2X minus 5. So we're going to set those equal to each other. We're going to get the X's to the same side by subtracting one of them. So we'll get X minus 5 on one side and a 3 on the other. And then we're going to get X by itself by adding 5 to both sides. So we're going to get X equals 8. And then we can come back and we can double check it to make sure that that makes sense. If I plug in an 8 here, I'll get 8 plus 3, which is 11. And if I plug in an 8 here, I'll get 16 minus 5, which is 11. So I know for sure the answer is 8. Cool. So guess what we're going to do over here? I wonder if there's 24 problems here too. Hey, look, there is. So guess what we're going to do here too? We're going to do every third problem. Okay, so we're going to do the first one together. Every third problem. Okay, so that means we're going to do 3, 6, 9, 12, ... until we're done. Okay, so we're going to go do number 3. So in number 3, here are our two chords, 12 and 3. So we know that 12 times 3 is going to be equal to this chord times this chord, which was 2 times x. And we're going to just solve that for x and find what x is. So on this side, I get 36 equals 2x, divide by 2, and I get 18. So we're going to go look at the bottom of the page and look and see if there's an 18. Bubble in all the correct answers. Hey, look at that. There's no answers on the bottom of that. How dare they? Sad face. Okay, so we're just going to have to be confident that we got the answer right. Okay, let's go on and let's find one with tangent problems. So the first one that has a 3 in it is going to be 18. Let's go back and circle all the same numbers again, just so that we know. Okay, so it's 3. Then we're going to do problem 6. We're going to do problem 9. We're going to do problem 12, 15, 18. Okay, so 18 we're going to do together. So again, we have a point outside here that creates two tangent lines. So here's the tangent line to F, and then here is the tangent line to E. And they are saying D to E is 12. How much is D to F? Well, they have to be equal. They have to be 12. Okay, so looking at the bottom of this page, I'm hoping there is. Happy day. Okay, and then let's go ahead and circle all of our 3's. So 18 plus 3 is 21. 21 plus 3 is 24. Okay, and that's going to be it for this week. So we're going to be practicing a little bit about formula for circumference. And remember, the formula for circumference is pi d, pi times diameter, or you could call it 2r width of times pi. Okay, we have the intersecting chords, right? And that idea that AB equals CD. And then we have that idea of that the tangents to a circle, if they connect to a line on the outside, have to be equal to each other. Cool, so that's what we're going to be practicing. Don't forget there's a quizzes assignment this week. I am recording that for a quiz grade, so don't forget, all right? Have a great week. We will see you for questions on Thursday. Have a good one, guys. See you later. Bye.